Welcome to The Explainer. Today we're talking about a brand new space race. But this one isn't about planting flags on the moon. Nope, this is about connecting every single person on Earth. We're going to break down exactly how satellites are about to completely change the game for global connectivity. Let's kick things off with a number that might actually shock you. We think of ourselves as living in a totally connected world, right? Well, get this. Wireless technologies cover less than 40% of the world's landmass. Think about that. A huge chunk of our planet is still in a communications dead zone. So, that begs the question, right? How do we solve this? How do we connect everybody else? Well, the people working on this are looking up, not across the land, but up into space. Okay, so let's get into what this solution actually is. It's a technology called non-terrestrial networks, or NTNs. And honestly, it's probably the key to finally closing that global digital divide for good. So what is an NTN? The easiest way to think about it is like this. We're putting cell towers in the sky. Instead of building thousands of physical towers and laying cables across the ground, the network just beams a signal up to a satellite, which then beams it back down to wherever it needs to go. Simple, right? But it can reach literally anywhere on the globe. Now, this is where it gets really interesting, because where you put that satellite in orbit changes everything. Down in low Earth orbit, or LEO, they're close and they're fast. That gives you super low latency, which you need for things like video calls. But as you go higher, all the way up to GEO, the satellites seem to just hang there in one spot. That's way simpler, but that huge distance means there's a serious time lag in the signal. And for now, you should know that most of these systems are pretty straightforward. The satellite itself isn't doing a ton of complex processing. It's basically just a giant mirror in space. It catches the signal from, say, your phone and just bounces it or repeats it down to a station on the ground that's hooked into the regular old internet. And this concept, as simple as it sounds, has kicked off a brand new, high-stakes space race. So let's take a look at the big players who are all fighting to build these networks in the sky. First up, you've got Starlink, and their approach is, well, massive. They're doing everything themselves, building the rockets, launching thousands of their own satellites, making the user terminals, the whole shebang. It's a huge, closed ecosystem designed to just blanket the entire planet with internet. Then, on the complete opposite end of the spectrum, you've got Apple. They're not trying to give you broadband. Instead, they've used this tech for one very specific, very critical purpose: emergency SOS. It's honestly an engineering miracle, getting a standard iPhone with its tiny, weak signal to reach a satellite in orbit when you're in trouble. And then you have these fascinating partnerships like T-Mobile and Starlink. They're chasing what a lot of people think is the holy grail here: connecting your regular off-the-shelf smartphone directly to a satellite. They're trying to use T-Mobile's existing cellular airwaves to essentially teach the satellites to speak the same language as your phone. No new hardware needed. And finally, there's the moonshot, the high-risk, high-reward play from companies like AST Space Mobile. They are trying to build gigantic satellites, we're talking huge antennas, to deliver actual broadband speeds directly to any normal smartphone. It is incredibly difficult, but if they pull it off, it changes absolutely everything. So if this stuff is so amazing, why aren't we all using it right now? Well, because the challenges are, and I mean this quite literally, astronomical. For starters, these LEO satellites aren't just sitting still up there. They are screaming around the Earth at over 17,000 miles an hour relative to you standing on the ground. And that mind-boggling speed creates a massive physics headache you probably remember from school: the Doppler effect. You know that sound an ambulance makes as it drives past you? That me-yo sound? That's the Doppler effect. Now imagine that, but with a radio signal. Your phone and the satellite have to perfectly adjust for that frequency shift in real time, just to stay connected. And the Doppler shift is just one issue. You've got a whole list of other massive problems to solve. The signal from your phone gets incredibly faint, traveling hundreds of kilometers into space. There's the built-in time delay just from the signal having to travel that far up and back. There's a traffic jam for the radio frequencies you can even use. And, of course, there's the growing problem of space junk as we launch more and more stuff into orbit. But here's the thing, there has always been one hurdle that was the biggest deal breaker of all: cost. Just getting things into orbit was astronomically expensive, and that is what is finally, fundamentally changing. Thanks to reusable rockets, launch costs have absolutely plummeted, making these wild, ambitious projects actually financially viable for the first time in history.
So, what's the end game here? Where is all this technology headed? Well, this isn't just about patching up dead zones anymore. This is about laying the foundation for the next generation of wireless technology, 6G.
The big idea, the grand vision for 6G, is to completely blur the line between the network on the ground and the network in the sky. Your device won't know the difference. It'll just be one single intelligent network that's everywhere.
And the promise of making this happen is just huge. First, you get total ubiquitous coverage. Everyone, everywhere is connected. Second, it's totally seamless for you. Your phone just automatically picks the best link, tower, or satellite, and you never even notice. And third, this opens the door for all kinds of futuristic tech, like truly autonomous cars or a global Internet of Things that absolutely require constant, unbreakable connectivity.
So will people actually pay for this? Well, it sure looks like it. The data is starting to show that a pretty significant chunk of us, about a third in some cases, are actually willing to shell out a few extra bucks a month to guarantee we're always connected, no matter where we go. Which brings us to one last big thought to leave you with. For all of human history, distance and geography have been our greatest limitations. When this technology finally erases that barrier for good, when every single inch of our planet is connected, what new ideas, what new businesses, what new ways of living will we invent? What do we build next? That's what we'll all be watching.